And now going ahead forward to our next session, we have a special presentation on steel slag utilization in agriculture as a fertilizer. Waste to Wealth by Dr. Bhupinder Singh, Principal Scientist, Indian Agricultural Research Institute. Can we have a big round of applause for Dr. Bhupinder Singh?
Thank you everyone for giving me an opportunity. Thank you Metalogic for giving me an opportunity to speak about a new dimension of converting waste from steel slag manufacturing into wealth. This is a humble beginning that we have made, and I would like to showcase what we have done in the past 2 years. Okay, thank you. This is what we are going to talk about is steel slag utilization in agriculture as fertilizers, and how we can convert this waste into a wealth opportunity. What we know is that the plants need nutrients irrespective of the source. The plants don't care from where we get the nutrients. They only need the nutrients to take care of to manage their health, and this is where we would like to utilize this opportunity. Now the country as a whole, is struggling with so many other challenges. We have deficiencies of the nutrients in the soil, we have toxicities, we have imbalance, we are going for nutrient deficiencies in the soil, we are having biofortification program, we are having fortification program where we are adding nutrients into the soil. If you see the graph here shows you that how the micronutrient and macronutrient deficiencies in the soils have grown over the years. And when we take care of this, we need to ensure anything that we want to add it to the soil, we need to ensure that we do not play or disrupt the normal functioning of the plant system or the ecosystem per se. Our country now, we are progressing natural farming, conventional farming, organic farming, conservation farming. Each of these is a different concept. Where we can apply this opportunity, where we can utilize this opportunity is something very, very important. And while we do so, we need to ensure that we do not disrupt the microbial environment or the biological activity in the soil. We do not disrupt the roots which are regarded as a hidden half. So we need to ensure that the nutrients that are there in the soil are available to the plant and through various means. Now the opportunity that we see, I will not go into the details of it, but what I would like to say is that the steel slag with a pH of about 11 has a rich source of calcium, magnesium, silica, phosphorus, iron and zinc to some extent. And this is where we would like that this can be used for taking care of the degraded soils, the soil acidity which is there in about 49 million hectares of our land. And also, as Mr. Jindal talked about cutting the cost of fertilizer, so that is where this also opportunity can be seized here. So this is our fertilizer requirement, and how we can curtail the fertilizer requirement by using steel slag as one of the opportunities. And when we talk about degraded soils, 11% of the earth vegetative surface is degraded. And can we use steel slag for reclaiming those degraded soils? This is also for acidic soils, the steel slag in an amended form can be a liming opportunity, and I have just calculated that the volume of requirement shall be equivalent to 100 million tons of liming material and about 300 billion rupees. And I will not go into the details of it, but this is where we come into picture with the help of the Ministry of Steel and also the Tata Steel, SAIL, as well as our Jindal Steel Works. We partnered at the behest of the Ministry of Steel, and we started a program where we wanted to use this steel slag as a source of fertilizer. And the only challenge was that while we use it, we need to ensure that it doesn't affect the soil health, it can be used, whether it can be used for the acidic soil reclamation, how best we can make it as a holistic nutrient source, whether slag can be converted into value added products as fertilizers or as amendments, and what will be its short term and the long term effect on the soil as well as on the biological activity, and whether there will be any phytotoxicities which will be coming along. And this is what is our achievement for the past 2 years. We have developed around 51 organically and inorganically amended steel slag, and we call them as steel slag based value added products. And we have evaluated these products over 31 trials in 12 crops at 8 locations, and it encompasses all different types of vegetables, be it cereals, be it oil seeds, be it the medicinal plants or aromatic plants or tubers. And we have taken care to address the soil physicochemical health. We have taken care to ensure that the chromium content, which is a major obstacle in utilization of steel slag, is kept at under 150 ppm. That is the FCO requirement, fertilizer control order requirement. And based on our research, we find we have identified 13 products which are now given to the industry for independent trials, and based on their performance we will be deciding. And along with this, 12 more products which are promising, those are in the pipeline and we are working on that. Just to give you a glimpse of it, we also discussed utilizing the city compost in this. But problem of utilizing city compost which is available in bulk is that it itself is a source of different, we cannot assure or we cannot determine the quality, we cannot we cannot regulate the quality of the city compost. So that was a major issue which deterred us from using city compost as a source of, as an amendment. And based on our research, this one slide will give you an idea that what we have achieved and what kind of biological intervention, chemical interventions we have induced to amend the steel slag for its utilization in agriculture. This is phosphorus rich steel slag, and you can see different centers where we have tested the crops, we have tested the kind of nutrients each of our amendment is adding to it. And we are using in this particular mixture, we are using 29.4% of the steel slag. So steel slag utilization in most of our product is about 25 to 35% we are using as of now. And we are also ensuring that whatever final product we are making, it is following all the requirements, the permissible limits of the hazardous and other impurities, be it zinc, copper, chromium, lead, cadmium, all these are within the permissible limits, so that we are ensuring. This is potassium rich steel slag, this is potassium phosphorus rich steel slag, this is sulfur rich steel slag, this is phosphorus sulfur rich steel slag, this is potassium sulfur rich steel slag, PKRS, there phosphorus is in higher quantities. This is silica based, enriched products which we have made, and this is a product which we have made for the acidic soils. AS is for acidic soil based steel slag. We have checked what in acidic soils the availability of the metals it is induced, but when we are adding steel slag based amendments, there is utilization of the nutrient and the plant is not taking up those heavy metal. We have even checked it with the arsenic rich. This is heavy metal contaminated. So we have done it in arsenic contaminated soils, and you can see here the percent reduction of the arsenic compared to the control in our product which we have now identified. It is 74% lesser uptake in the food chain, even on the contaminated soil. So that means the grains which are produced on those soils, farmers will be cultivating, madam, they will be cultivating those land irrespective, we say, they will be eating also. But when we are adding the slag based fertilizers to that, the movement or the translocation of arsenic from the soil to the plant or to the grain, it is reduced considerably by about 74% using our product. This is in general the yield increase across the products that we have got across crops. It is about You can see about at around 10% in potato, we are having 90% of the yield increase with our products. And this is different products. We have checked it in wheat, we have checked it in brassica, green gram, soya bean, chickpea, rice, mustard, potato, French bean, pea, lemongrass, and ashwagandha. So these are the products which are doing good across different crops. And we are also, somebody was talking about, as is the CO2 emissions, reduction in CO2 emissions important for steel production, so is also important to reduce the CO2 emissions or the greenhouse gas emission from the agriculture. So we also managed to, we also checked the N2O emission, which is a major green gas when we are applying any nitrogenous fertilizer. You can see the first bar on the top will be the conventional, the pink line is the conventional, and the lowest bar is when we are not applying any fertilizer. And in between, when we are applying steel slag along with the recommended dose of fertilizer, there is a reduction in the GHG emissions. So that is also a take-home message from this. This is just a very important thing, that we also manage whatever amendments we are proposing, whether there is availability of those amendments and what is the annual availability, whether there will be any limitation in terms of the availability of those amendments. So we find that those, whatever we are working on, the amendments which we are proposing, those are available in plenty. And second is, I think this slide will not be visible. What we are proposing is that even when we are trying to use it at 1 ton or 2 tons per hectare with 40% capacity, we will be able to utilize, even I have taken the data of only 5 crops here, 5 major crops. We will be able to utilize from 5.74 million tons to 11.48 million tons of steel slag through this route, even when we are only targeting over only 15% of the area. The total production area of the crops, only 15% I am targeting. You can say even 10% to start with. Even when we are starting at 10%, it will be about 8 to 9 million tons of steel slag utilization through this route. And we have also calculated, we can always work on the economics, but the whatever limited information, limited expertise I have, we have calculated the total cost per ton. And the production cost is about 2 to 3, sometimes for some of the amendment it is 5 to 6 rupees per kg. So this is the conclusion slide. The steel slag application, Mr. Jindal was asking about steel slag direct utilization. Sir, it is not sustainable at all. And the reason is that the pH of that the slag is about 11. And at such high pH, it is, if we use it for 1-2 years, it is going to cause alkalinity of the soil. We can use it on acidic soils directly, but there also the high chromium content of the steel slag and high nickel also we found in some of the slags. We have tested with 3 slags. I don't want to name it, but the point is, I was told that when you are going for recycled steel slag, then recycling of steel, the process of utilizing that recycled steel will add some impurities, maybe nickel or some other things to that. I am not a man of, so please pardon my ignorance, but our job as an agriculture scientist is to ensure that whatever we add to the soil, it is as per the permissible limits, and it does not add anything which we don't want our child to have in the food chain, through the food chain. And this is our steel slag based value added products have lower than permissible limits of heavy metals, and this we have done it for 2 seasons now. And the produce also doesn't show any phytotoxicity and does not cause accumulation in the multiple cropping seasons in the soil. And the good part is, we did all this experiment. If NPK requirement for any crop is 100% recommended, wherever we are using our products, we are adding along with only 80%. So we don't want that use of steel slag based fertilizer should be an additional burden to the farmer. We are cutting on the cost of NPK and telling the farmer that you can use our product along with 80% of we can even bring this limit lower, but to start with, our members and our team, they thought that it will be better to start with 80% of the 20% reduction in the NPK use and see whether our amended fertilizers can supplement those nutrients which are not otherwise, being provided. And average cost of production of the product is 2,500 to 3,000 per ton. This is an average cost, and we are having a 20% saving. Many of the products where we had P enrichment, potassium enrichment, we can completely cut down the application of P or K, because this is what experiment we have done. So we can even save on the total cost of P and K. This is, we are always encouraged by the stakeholders, and this is the field visits by different stakeholders across the companies, the farmers also, they are part of it. And these are the products which we have made. These are always shown to our team. And the trials are run at about 8 locations. And I was very much encouraged by the words of Mr. Jindal in the morning, that he is looking forward to utilization of steel slag in fertilizers. Sir, these kind of words, they always motivate us and ensure that we do better and better without compromising on the quality, as you all vouch for. And thank you very much for giving me an opportunity. I would like to thank the ministry as well as the sponsors for giving us this opportunity, and also to Ms. Monica, the Metalogic team, for giving me the opportunity to stand and share what we have worked for. Thank you very much.